Alright, so that was a quick video introduction on systems of equations, which is what our unit is on. We're going to look at how to solve a system of equations, first of all, by graphing today. So a system of equations, as was mentioned in the video, is two or more linear equations with the same variables. For instance, we have two equations down here and they both use x and y. So that would be a system of linear equations because we have two equations using x and y. A solution of the system is the ordered pair that satisfies both equations, or if there's more than two equations, any of the equations in the system. So let's first of all look at how to check if an ordered pair is a solution of the system. So check whether 1, 2, and 3, 1 are solutions of the system. So what we need to do is just plug in the values and check to see if they are a solution. So let's take a look at these equations first of all and check if 1, 2 is a solution. Okay, so what we do is we plug in the x and the y. So if I put 1 in for x and 2 in for y, I get 1 plus 2 times 2, which is 4. And does that equal 5? Yes. Okay, so that works for the first equation. Does 1, 2 work for the second equation? Well, 2 times 1 is 2. Minus 3 times 2 is 6. And does 2 minus 6 equal 3? No, it does not. So 1, 2 is not a solution of the system because it does not satisfy each equation, just the first one. So let's try the next one, 3, 1. So if we plug in 3, 1 to this equation, 3 plus 2 times 1 is 2. 3 plus 2 equals 5. Yes, that one's a solution for that equation. Is it a solution for the other equation? 2 times 3 is 6. Minus 3 times 1 is minus 3. And does 6 minus 3 equal 3? Yes. So 3, 1 would be a solution for this system of equations because 3, 1 satisfies both equations. Okay, so in order to be a solution, it needs to work for both equations. Now, taking a look at the graphs, when we graph the equations, we find the ordered pair that is the solution, the ordered pair that satisfies both equations. In this case, our solution is 1, 2, because that ordered pair works in both equations. It's a solution for both of them. Whereas I've got an infinite number of equations or solutions on the green equation and an infinite number on the blue equation, 1, 2 is the only one that works on both of them. What's the ordered pair that works on both of these? Well, I can tell by looking that these lines are parallel. So they're never going to meet, so there is no solution for this system of equations. There's never a time when these equations will meet. And down here, I have two lines right on top of each other. So we would say that this is infinitely many solutions. No matter which point we choose, if it's an equation or if it's a solution on the blue equation, it will also be a solution on the green equation because they have the same points, infinite number of solutions. Okay, so those are the three main types that we'll come across, either one solution, or no solutions, or infinitely many. So keep that in mind as we graph our systems of equations. We can also take a look on a table. That introduction video showed you how to find the solution on the table. It has the same x and y values. So if we're looking at a table, what is the solution to this system of equations represented by a table? I think you can see it. It would be 2, 7. that's where both equations are the same. 4 and 11, 4, 13 are different. So the only time they're the same is 2, 7. So that is our solution for that one. So we can do it visually on a graph or visually on a table. We're going to work now on figuring out how to graph two linear equations, or a system of linear equations, graph the two linear equations, and find out what their solution is. So in order to do that, well, first of all, we need to graph each equation. And once we graph both equations, then we can identify the points where the lines cross, and then that would be our solution. We can check it in both equations. So this one starts off well. It's in slope-intercept form, so I know the intercept is going to be -7. 3, 4, 5, 6, 7. So I start off at -7. And its slope, well, it's 1x. So my slope is up 1 over 1. And I can just keep drawing points on there to make sure I get an accurate line. I'm just going to keep drawing them up there. And then the next equation. I'll switch colors so it can look different. Let's go purple. So my intercept here is 5 on the y-axis. And my slope is -2. So if I go down 2 over 1, down 2 over 1. Oops, I think I counted wrong there. 1, 2. And then down 2 over 1. I see that I've hit a point where they're both in the same location. I can connect those lines. I probably want to use a straight edge to be more accurate. But if I'm just putting all the points in and they meet at one specific point, I can tell where my solution is. So in this case, my solution will be right here at 1, 2, 3, 4, -1, 2, 3. So 4, -3. And I can double check to see if that is a solution and put those into both equations just to make sure that I have the right point in case I graph something wrong. So if I plug 4 in for x, my y should be -3. So 4 minus 7 is -3. Works for that equation. If I put 4 in for x, -2 times 4 is -8. Plus 5 should equal -3. And it does. It checks out. So 4 and -3 will be our solution for that one. Why don't you try the next one? Pause the video and restart it when you're ready. Okay, so as you can see, I graphed y equals -3x plus 3 with the yellow dots. Intercept of 3, slope of -3. Just made points all the way down. And then the green equation, y equals 2x minus 2 with green dots. Start at -2 on the y-intercept and slope of 2, up 2 over 1. When I was drawing my dots in, I found out that they crossed at 1, 0. Then I drew the lines in. And then I can check 1, 0. -3 times 1 is -3, plus 3 is 0. 2 times 1 is 2, minus 2 is 0. Since it checks out of both equations, I know that I did that correctly. Okay, so now what happens if the equations are not in slope-intercept form? Well, nothing's really different, and you know how to do this already. So what you would do is just change both equations into slope-intercept form, graph both equations, find out where they cross, and check your solution. So nothing's really different. So why don't you try these on your own, pause the video, and start it again when you're ready. Okay, so as you can see, I solved the first equation, got it into slope-intercept form, got the y by itself. So I had an intercept of 9, slope of -2. Plotted those points on my graph in blue. Next equation, 2x plus 3y equals 15. I got that one into slope-intercept form by subtracting 2x from both sides and then dividing by 3. So I had y equals -2/3 x plus 5. And that equation I had graphed in green. I used green dots, so my y-intercept was 5, slope of -2/3. And I found out after graphing those that it crossed at 3, 3. And that would be my solution, so I can check it to make sure I'm right. 2 times 3 is 6, plus 3 is 9. It works for that equation. 2 times 3 is 6, 3 times 3 is 9, 6 plus 9 is 15. So it is a solution for both equations. So that is how you solve a system of equations by graphing. Remember, a system of equations as we defined it earlier, is two or more linear equations with the same variables. The solution is that order pair that satisfies both equations, or all equations if there's more than two in the system. Keep in mind they'll have one solution, or no solutions, or infinitely many when we're talking about linear equations. There's the three possibilities you can have when you are solving a system of equations. You got some practice work to do. Any questions? I can help you out in class.